Hey guys, Art Lembo here, and I am going to be talking to you about some work we're doing this summer as part of a National Science Foundation research experience for undergraduates, where we're performing some high-performance computing with ArcGIS using graphical processing units, or the Compute Unified Device Architecture offered by NVIDIA. So I'm working with two students, Sean Kirby of the University of Maryland Eastern Shore and William Costin from the University of Virginia. We're focusing our work primarily, or actually exclusively, on raster-based data, and specifically on focal functions within a raster-based analysis. As you know, focal-based functions really are focused on the center cell within a kernel of 9 different pixels. Now, because we're focused only on the center cell, this means that this operation can be performed independently of all other operations on the device. And we call this embarrassingly parallel, because we can work on the middle cell for this kernel, and then we can work on other middle cells and not have to worry about what's being computed for this particular cell. So the idea is using graphical processing units on the computer or on the video card that's offered by NVIDIA to take a series of grids you see here and actually send each kernel to different GPUs to perform the operations in parallel. Now, some of the issues we're dealing with is how to deal with the memory management, getting the data onto the GPU in the appropriate manner, and there's a lot of different strategies for that, how we interact with the file, and then some of the bottlenecks that we run into when working with the card and then having to get the data back on the actual device. To illustrate what we're doing, I'm going to look at Howard County, Maryland. Here's some LiDAR imagery. And this imagery actually has about 336 million pixels. So in Model Builder, I built a little model. And what I'm going to do is turn off the video as I run this, but show you the times. So we're just going to run slope. Oh, let's try it again. So let's run all the entire model. And I'll turn the video off, and we'll come back when it's completed. Well, we're back, and you can see that ran in 46 seconds. So not too bad for 300 million pixels. Now, I also went out to Walmart and bought a CyberPower PC for about $1,000, and this has 16 gigabytes of memory as well as an NVIDIA card with approximately 500 graphical processing units on the card. So here's an example of our parallel processing using an ESRI float grid. I'm going to run this, and it's going to ask me for the directory. Right now, we've got it as a command line prompt, but we'll eventually build it into a tool, and the file name is Howard_1. And we aren't going to calculate the terrain ruggedness. We've done that. We've also calculated slope and aspect. So we're just going to calculate slope, and we'll let this run. So it's running different kernels. It's actually split the entire job over 3 different processes on the card, and it's done. So that took about 7.8 seconds. So in just a short time that we've worked on this, we've gone from 46 seconds down to about 8 seconds, and depending on the size, we're working with some larger ones, we're seeing greater increases as well, and sometimes we're seeing as much as a 20-time improvement. So I'm going to make some more videos with some of our really larger data sets where we get into about 1 billion pixels, just to let you see the differences.